Hello everyone, I'm Ruchu Zhang, a data solution engineer in the Data EMEA team and co-developer of Greenplum Python. Today's presentation is entitled Managing and Analyzing Greenplum Data with Python. So in this presentation, we'll explore how Greenplum Python, also named PyGP, a Python library that provides a Pandas-like table API to interact with Greenplum, a parallel PostgreSQL platform, can be used for complex analytics and manipulation of data. To kick off, let's delve into the traditional methods used by programming languages, such as Python, to process database manipulation, as well as the limitations they pose. Following that, I will introduce Greenplum Python, a Python library designed to address these challenges, and I will explain how it can simplify complex analytics and data manipulation, making it easier for data scientists and engineers to work with large data sets. To showcase in action, I will demonstrate how it can be used to express SQL queries and provide a demo of manipulating a large data set that cannot be handled locally. Lastly, I will discuss its compatibility with Pandas and how this enables Greenplum Python to be integrated seamlessly into existing data workflows. So let's begin by examining traditional methods used by programming language to manipulate database. We know that SQL is the most commonly used domain-specific language for interacting with database, while general-purpose programming languages are used to build applications. So Python developers have traditionally concatenated SQL statements manually to manipulate database, as exemplified in the Greenplum utility GPLoads Python code here. However, this approach has significant limitations, including cumbersome processes. The written programs are not intuitive enough to maintain, difficulty in obtaining code hints from programming tools and inefficient programming, and hard to spot possible errors before running and prone to security issues. To overcome these limitations, data analysts and scientists turn to Pandas, the most widely used Python library for local data manipulation and analysis, to export data from database to local environments for manipulation. However, Pandas is not designed for handling large amounts of data, which present challenges in terms of data size and processing speed limitations due to single-threaded execution and thus underutilizing local CPUs. And to address all of these limitations, we need a set of APIs native to the programming language that allow us to express database queries succinctly and intuitively using language's structures. This API should also maximize access to code hints and static checking tools to improve programming efficiency and catch errors early. Also, they should enable data manipulation directly in the database to scale to large amounts of data. And as a solution, we introduce Greenplum Python. As I have presented, Greenplum Python is a Python library that provides a set of programming language native APIs for facilitating database manipulation. It's designed specifically for Python users, enabling data analysis without the need to export data to local machine. Basically, it's installed on the client side, either locally or on a remote server, and can be used within Python environments such as Shell or Jupyter Notebook. And with Greenplum Python, users only need to write Python commands, and the library will transform these commands into SQL queries on the backend and execute them in the database where large amounts of data are distributed across different segments. Users can also write user-defined functions, UDFs, and aggregate functions, UDAs, as Python functions. And it's important to mention that in order to utilize any Python packages in this UDFs or UDAs, these packages must be installed on both the coordinator side and segment sides. And fortunately, this process can be streamlined by installing the VMware Greenplum Data Science Python bundle, which offers a wide selection of Python packages for data analysis and science. To summarize, Greenplum Python provides a Pandas-like stable API that looks familiar and intuitive to Python users, making it easy to get started and supporting code hints and static checking tools. It's efficient, scalable, and secure data processing directly in the database, maximizing Greenplum analytics performance and massively parallel processing scalability. Its ability to break down complex SQL queries into multiple simple Python commands, encapsulating best practices and avoiding common pitfalls in Greenplum compared to writing SQL directly. And lastly, support for complex analytics such as statistical analysis, using UDFs and UDAs that support rich Python libraries, which enables users to analyze data in a variety of formats and structures. So if I summarize, Greenplum Python is a powerful, efficient tool for database manipulation and analysis, enabling users to leverage the full power of the Greenplum database directly from their Python environment. And all of the above features can be realized thanks to data frame, the core data structure in Greenplum Python, which conceptually is a two-dimensional structure containing data. If we compare Greenplum Python data frame to Pandas data frame, it's very similar, except for some key differences. So firstly, data in a Greenplum Python data frame is lazily evaluated, meaning they are computed only when they are observed, resulting in improved efficiency in many cases, while data in Pandas data frame is evaluated eagerly. Secondly, data in Greenplum Python data frame is located and manipulated on a remote database system, while for Pandas, it's locally. This is in the data science world. If we switch to the database world, a Greenplum Python data frame is similar to a materialized view, as they both result from a possibly complex query and whole data. And as a result of concurrent modification, the data can become stale. So this is the difference and the similarity between Greenplum Python data frame and Pandas data frame and materialized view. Now I'm going to present the main functionalities of Greenplum Python in this slide. So to start, using the library, we can import it with import Greenplum Python and connect to a database using a dictionary of database information or its URI. The library offers various functionalities such as creating data frames from existing tables in the database, selecting a subset of data, joining data frame based on specified conditions, and most notably, creating and calling Python functions on a data frame. So for instance, if we have a Greenplum Python data frame df with two columns, A and B, and want to get the sum of these two columns by applying a Python function executing in database, we can simply add the @gp.create function decorator before the function declaration. And this creates a corresponding UDF in the database using the default pure Python 3U language extension, which we can then call in the same way as a local Python function to apply it on columns A and B of data frame df. So this is the basic main features of Greenplum Python. You can find more in the Greenplum Python documentation. Now let's take a look at some illustrative examples of how to express SQL queries with Greenplum Python. So to start, you can find SQL queries on the left hand and Greenplum Python commands on the right hand. Let's suppose we have two lists of products and category information. We can easily create two data frames from this list, row 1 and row 2, without writing any explicit SQL syntax. Instead, we simply use the create data frame function and passing the rows as arguments. And as a result, we obtain two data frames, categories, and products. If we need to analyze data from an existing table, we can use the create data frame function again. But this time, we pass in the name of the table. So here, table products. And Greenplum Python will create a data frame for us and query the database. And now suppose we want to find which two products in our table products have a significant price discrepancy within the same category. In SQL, we will need to join the products table with itself and filter the result based on category and price difference twice. However, with Greenplum Python, we can assign the join result to a new data frame and use it multiple times, making the code more concise and efficient. Now, let's dive into a new section and explore how Greenplum Python can help us manage and analyze large data sets. To demonstrate, let's take a look at a demo. So now I'm going through a use case I presented in a blog that shows how to use the Greenplum Python package to process and transform a large news dataset. This dataset has up to 132 million rows, which is impossible to handle locally with Pandas at once. So to get started, we'll need to install the package by running pip install Greenplum Python. Next, we'll initialize the Greenplum session with the parameter dictionary or connect to the database using the connection URI. It's nice to know that the Greenplum Python connection uses a PsychoPG2 driver since it's a PostgreSQL-based database, and the connection URI follows the same specification in the libpq document. So once we are connected to the database, we can create a data frame to access the news table by specifying its name. To do so, two methods exist, one of class data frame and one of the class database, and both result in the same result, which means the data frame. Now we have our data frame DF. We can do basic data manipulation on it, just like in SQL. To start, for a quick glance, we can select the first two unordered rows of data frame. We observe that it contains 4 columns: content, title, doc ID, and date. We can just select a subset of columns, date, and title, or we can select a subset of its rows filtered by conditions with method where. For example, here, I just want filter specific date range news since 1st January 2020. If we want result to be ordered, we can use the function order by. This is very useful for many analytical tasks, such as statisticals. So here we want just the top 5 recent news. So Greenplum also supports creating Greenplum UDFs and UDAs from Python functions and coding them in Python. You can create such functions with decorators gp.create function or gp.create aggregate, and you need to specify the type of input and output of functions. For example, here, we want to create a function which takes input as a string date, and will extract the first 4 characters of the string as output. So we can use this UDF to assign a new column year to our data frame by giving column date as input. And as a result, we obtain this. And of course, date need to follow this format. To create a UDA, we only need to write its transaction function in Python. So here, the UDA max length takes the string val as input. Result is the intermediate value of the UDA. So if result is none, it means if the first value to be compared, we simply return the length of this val. Otherwise, we compare the length of val and result to update result. And by the end, we obtain the maximum length of val. So by applying this function to column content, we obtain the maximum length of news in this data frame is 107. And to be sure, if we apply the built-in aggregate function marks on the column news length, we obtain the same result. Finally, we can save the resulting data frame to the database as a table, either temporarily or persistently. And moreover, we can specify storage parameters with the storage params attributes. For example, here I set append optimized to true. So that's it for the demo. You can find this article on greenplum.org or Medium if you want to read the details. And now let's get back to slides. In this demo, we can explore how to create and call Python UDFs with Greenplum Python. This approach offers several advantages. Firstly, unlike normal Python functions, UDFs are executed inside the database, which eliminates the overhead of moving data around. Secondly, UDFs are versatile and can meet a wide range of data analysis needs, allowing Greenplum to analyze not only relational data, but also non-relational data. And this can simplify enterprise information system architecture. And lastly, Greenplum can automatically parallelize UDFs when data is distributed across multiple nodes. This allows UDFs to process large-scale data more efficiently than a standalone Python program. Now, let's go to our last section of today. We'll examine how Greenplum Python syntax compares to Pandas and explore the Pandas compatible package offered by Greenplum Python for a seamless experience. In this slide, on the left column, we have Pandas methods, and on the middle, Greenplum Python. When comparing these two syntax, we can see that they are named differently. To provide a familiar experience for Pandas user, we developed a Greenplum Python Pandas compatible package. You can see its method on the right column. This package can be accessed by importing Greenplum Python.pandas, and does the same manipulation on the backend as Greenplum Python data frame, and offers the same method names and parameters as Pandas. However, the current number of methods offered by this Pandas compatible package is limited. So to access more functionalities, users need to convert data frame from this Pandas compatible package to Greenplum Python to explore more possible cases. To conclude, we hope that you have gained a better understanding of how Greenplum Python can simplify interaction with Greenplum and improve productivity. We believe that it's a powerful tool that can enhance the capabilities of data analysts and data scientists. So if you can find. To conclude, we hope that you have gained a better understanding of how Greenplum Python can simplify interaction with Greenplum and improve productivity. We believe that it's a powerful tool that can enhance the capabilities of data analysts and data scientists. You can find more learning materials of Greenplum Python from its documentation page or on greenplum.org. To finish, thank you for your attention, and we hope that you will consider using Greenplum Python in your future projects. We welcome any questions, remarks, and feedback about Greenplum Python. So please feel free to ask us anything, provide feedback or suggestions, and share your experience using the products. Thanks very much.